Welcome to Fertility Nest. Fertility Nest is built on a modern, scalable tech stack designed to deliver a fast, secure, and deeply personalized experience. The mobile app runs on React Native, with Firebase FCM managing real-time reminders and notifications. A powerful .NET Core backend handles authentication, tracking logic, community features, subscriptions, and AI routing, all backed by a structured SQL Server database for reliable data storage and analytics. The entire platform is hosted on Azure App Services, with Azure Security, Key Vault, and Azure Backup ensuring enterprise-grade protection and disaster recovery. Emails and OTPs are delivered through Microsoft Graph API, while images and static assets load instantly through a global CDN. Anira, the in-app AI companion, is powered by Azure OpenAI, using user context to generate personalized guidance. Development, deployment, and project workflows are managed through Azure DevOps, and all UI/UX design is crafted in Figma for consistency and precision. A personalized all-in-one reproductive health and wellness platform. Fertility Nest adapts to each user's unique life stage and concerns, whether that's period tracking, fertility management, IVF, IUI, pregnancy, or PCOS. It's designed to guide and support users throughout their entire reproductive journey with care, intelligence, and empathy. Purpose and design overview. Fertility Nest was designed around a simple idea. Every person's reproductive journey is unique, and the technology supporting them should adapt, not the other way around. To make that possible, the platform is built on 6 core pillars. 1. A continuous, stage-aware health journey. Whether someone is tracking periods, going through IUI, IVF, or progressing through pregnancy, the system keeps a single, unified health record. Switching modes doesn't reset anything behind the scenes. SQL Server stores everything in structured models, so insights stay consistent as the user moves through different stages. 2. Personalized guidance through Anira. The app's AI companion isn't just a chatbot. Each message is processed through Azure OpenAI, with the system attaching context, like the user's current mode and recent logs, to ensure responses feel relevant and supportive. 3. Accurate tracking and clear reporting. Every symptom, mood, medication, cycle detail, or milestone is logged through structured forms. These entries flow through transactional APIs to keep data clean and consistent, while the app uses cached and server-generated summaries to power its reports, charts, and calendars. 4. A community that feels safe and supportive. Users can join topic-based groups, share experiences, or seek help. Moderation pipelines keep discussions healthy, and anonymous posting gives people a way to participate comfortably. 5. Partner collaboration without compromising privacy. Partners get a dedicated dashboard. They can see cycles, notes, and reminders, but only what the user has chosen to share. Permission scopes in the backend ensure data stays protected. 6. A UI that adapts to the user. The interface is dynamic. Based on the user's chosen mode, the backend provides configuration maps that adjust dashboards, quick actions, and tracker tools. Meanwhile, global tabs like Anira or Community remain constant for easy access. Starting the application. When the user opens Fertility Nest, the React Native app loads its core modules and checks stored flags in AS Sync to decide whether the walkthrough needs to be shown. If onboarding is incomplete, the walkthrough screens are rendered from a small local JSON config, so they can be updated easily. Before moving forward, the app calls a small backend API running on Azure App Services with .NET Core to check app version, maintenance status, and feature flags. Only after this check does the Terms of Use screen appear. Once accepted, the response is saved in secure storage, and every login request includes this flag for compliance. Authentication layer. On the login screen, when the user enters credentials, the app sends the data over HTTPS with TLS 1.3. The .NET Core backend looks up the email in SQL Server, compares the submitted password with a salted, hashed version stored in the database, applies rate limiting to prevent brute force attempts. If the credentials are valid, the server returns a JWT token signed by keys stored in Azure Key Vault. The app stores this token in secure storage, keeping it protected even if the device is rooted. If a user selects Forgot Password, they enter their registered email, and the backend sends a password reset instruction email to guide them through creating a new password. User registration and security. Registration is straightforward on the surface, but there's a lot happening underneath. On the device itself, fields are validated immediately, no empty inputs, proper email format, and a real-time password strength check. Users can toggle password visibility. When they submit the registration form, the backend revalidates everything. SQL Server checks for duplicate emails. Passwords are hashed and encrypted before storing. A transactional insert creates the user, profile, and audit logs. If anything fails, the transaction rolls back to keep the data clean and consistent. Once the account exists, the app asks for a few more personal details. These help calibrate predictions and recommendations from day one. Choosing a mode. The next step is selecting what the user wants to focus on: IUI/IVF, period tracking, pregnancy. That single choice triggers a back-end update. From that point on, the entire experience shifts. Dashboards, calendars, insights, and even quick actions load according to the selected mode. Bottom navigation bar. The bottom navigation is dynamic. React Native builds it at runtime using configuration returned from the backend. That's why the Tracker tab changes labels with each mode: IUI/IVF/FET, Cycle Tracker, Pregnancy. This approach keeps navigation familiar while letting the system adapt in the background. IUI/IVF mode. Once a user selects IUI or IVF, the app fetches the relevant treatment schemas, medication types, scan categories, and appointment definitions. Inside this mode, the calendar pulls events straight from indexed SQL queries. Quick actions let users log trigger shots, symptoms, moods, medications, scans, and treatment phases. Reports compile treatment timelines and upcoming appointments. Notes let users record anything important along the way. Quick actions rely on a combination of predefined fields and user-created custom fields. Each action triggers a post call, updates the backend, refreshes the local cache, and re-renders the affected components. Period tracking mode. Users start by entering two details: last period date and average cycle length. The backend runs a prediction algorithm to calculate fertile windows, ovulation dates, and expected periods. The cycle tracker screen displays a calendar with predicted and logged events, quick actions for recording symptoms, moods, and notes similar to the previous mode. It also contains predefined as well as custom options: a today's summary card generated directly from synced data, and a section to create notes. Additional tabs include reminders to keep all reminders at one place. History contains all previous cycles retrieved via indexed lookups. Everything stays synchronized, so insights become more accurate over time. Pregnancy mode. Pregnancy mode begins by asking for a few key details: the last period start date, the expected due date, and the pregnancy type. Once the user enters this information, the backend calculates their exact gestational week using standardized clinical formulas. This gestational age becomes the anchor point for everything shown in the app, from daily tasks to educational content. The backend then returns a package of week-specific configuration data. This includes what symptoms to monitor, which checklist items to prioritize, and what content modules should be visible. With this approach, the user doesn't just see generic pregnancy guidance, they see information that matches their precise stage. Daily checklist. At the top of the Pregnancy tab is the Daily Checklist, designed to give users a clear snapshot of what they should focus on today. It includes a progression card showing how far along the pregnancy is, a calendar automatically filled with scheduled medications and upcoming appointments, quick action buttons that let users log symptoms, medications, and mood within seconds. Each checklist item is generated from back-end rules tied to the user's gestational week. This means as the pregnancy progresses, the items evolve automatically without requiring user input or app updates. Symptoms, medications, and mood logging. Each time a user logs a symptom, medication, or mood, the app follows a structured and validated workflow. But an important detail is how these work. For each symptom, medication, the system loads a set of predefined options from the back end. These lists are maintained in SQL Server, indexed for faster lookup, delivered through lightweight configuration APIs, and updated without requiring app updates. However, real-life pregnancy experiences don't always fit into predefined categories, so if the available options aren't enough, the user can create their own custom entry. Technical behind the scenes. When a user creates a custom option in any of the modes, the app marks it as a user-defined value. A post request sends it to the backend. The backend stores it in a separate custom options table linked to the user ID and field type. On future log screens, the app merges predefined options, the user's custom options. This combined list is cached locally for fast access. This ensures the experience feels personal and flexible while keeping the backend structured and analytics-friendly. Now, whenever the user logs something, the app validates the entry, sends a transactional request to save it, updates the local cache, and refreshes UI components immediately. Over time, these logs improve insights in reports, weekly guides, and AI responses. Pregnancy mode also includes a suite of lightweight trackers designed for everyday use: water intake, baby kick count, vitamins, and supplements. These trackers update locally first for quick responsiveness, then sync with the backend in periodic intervals. This design reduces the number of API calls, improves app speed, and keeps data consistent across devices. Hospital bag checklist. Users can check off items as they pack and create custom additions when needed. Behind the scenes, the checklist state is synced with their profile so it stays consistent across devices. Reports. The Reports section consolidates everything the user logs throughout their pregnancy. The backend retrieves all related entries, processes them through summary algorithms, and returns easy-to-read charts, trends, and insights. As users log more over time, these reports grow richer and more accurate. This makes it easier for users to understand patterns in symptoms, medication usage, moods, and overall pregnancy milestones. Weekly guide and resources. In this section, the app delivers curated, stage-appropriate educational content: articles, videos, checklists, wellness recommendations. All of this content is fetched based on the user's current gestational week, not just the general pregnancy stage. This ensures the information is timely, relevant, and clinically appropriate. The backend stores content in a structured format, so the app can dynamically pull what's needed for that week, and the system can update or improve content anytime without requiring users to download a new version. Anira, the AI companion. Anira is available at any moment, functioning as a real-time AI companion throughout the user's reproductive journey. When someone types a question or selects a support category, the app prepares a structured request for the backend. This request isn't just plain text, it includes rich contextual metadata such as the user's active mode, period, IUI/IVF, pregnancy, their recent logs, symptoms, medications, moods, milestones, personalized settings and preferences, safety filters, and moderation parameters. The backend then builds a unified context package and sends it to Azure OpenAI, which processes the prompt and returns a structured, empathetic answer. Depending on the query, the response may include emotional support, factual educational guidance, step-by-step instructions, risk flags handled through safety rules, personalized suggestions derived from the user's tracking patterns. This context-aware exchange ensures that Anira doesn't behave like a general chatbot. It feels attuned to the user's stage, needs, and emotional state. Over time, as users continue logging and engaging with the app, Anira's guidance becomes increasingly relevant. Community. In the Community tab, users can join specific groups that match their interests or reproductive stage. When they join a group, the app sends a request to the backend, which registers their membership and gives them access to that group's posts and discussions. Rules and moderation. Every group follows a set of 5 fixed community rules. Whenever a user creates a post, asks a question, uploads an image, or starts a poll, the content is sent to the backend and passed through a moderation pipeline. This includes checking for inappropriate or harmful language, validating media and attachments, ensuring the post follows community guidelines, and logging actions for audit and safety. Only after these checks does the backend save the content. If someone prefers not to reveal their identity, they can join and post using a custom display name. The system stores this alias separately from their real profile, so the group only sees the alias, while the backend still maintains moderation control. Inside each group, users can create discussion posts, upload images, add voting polls, ask questions, reply to others. Each of these is handled through structured API calls and stored in the database with proper tagging so it can be displayed and retrieved efficiently. Profile and settings. The Profile tab loads all key user information from the backend, including name, date of birth, and phone number, all editable through the Edit Profile section, partner link status, current subscription plan. Any updates made here are sent to the backend via secure API calls, ensuring the information stays synced across devices. Partner link and share. To invite a partner and unlock shared view features, users must upgrade to a subscription plan. Once subscribed, the system enables partner linking, premium guidance tools, and priority support. The app generates a secure invite token that partners can use to connect their account. Upgrade page. The upgrade page allows users to view available plans, compare features, and switch from a free plan to monthly or yearly premium options. Subscriptions can be purchased securely through Google Play's in-app purchase, ensuring a smooth and reliable checkout experience. Once the purchase is confirmed, the backend instantly updates the user's subscription metadata, unlocking premium features across the app without requiring a restart. Settings tab. The Settings tab provides deeper control over how the app behaves. It includes profile settings, period settings, notification preferences, cycle trends and analytics, and appointment reminders. Within the Symptoms and Mood sections, users can edit the predefined lists or create custom entries of their own. Custom items are saved to the backend and merged with system-defined options, ensuring they appear everywhere relevant, from logging forms to analytics. Conclusion. Every part of Fertility Nest, its adaptive UI, secure backend, and emotionally intelligent AI, was built to make reproductive health easier to understand and easier to navigate. It's a system designed with empathy, backed by engineering, and crafted to support people through some of the most important chapters of their lives. Thank you for exploring Fertility Nest. Technologies used. Fertility Nest is built on a modern, scalable architecture designed to support real-time tracking, secure data handling, and seamless user experiences across all reproductive stages. Here's a look at the core technologies powering the platform. Mobile application. React Native. The mobile app is developed using React Native, enabling cross-platform deployment on both Android and iOS from a single codebase. It uses React hooks, secure local storage, and modular components to deliver fast UI rendering and offline-friendly user interactions. Push notifications. Firebase FCM. Firebase Cloud Messaging (FCM) handles all push notifications, including cycle reminders, medication alerts, partner updates, pregnancy milestones, The token generated on each device is registered with the backend, allowing precise and secure message delivery. Backend, .NET Core. The backend API is built using .NET Core, chosen for its performance, scalability, and structured framework. It manages user authentication and JWT token handling, mode-based logic, period, IUI/IVF, pregnancy, data validation and transactional operations, AI request routing for ANIRA, community posts, moderation and polls, subscription and payment logic. Backend logs, error traces, and performance metrics are tracked through Azure's built-in monitoring tools. Database, SQL Server. All logs, symptoms, moods, medications, pregnancy milestones, cycle events, community content, and subscription metadata are stored in Microsoft SQL Server. Key features include indexed queries for fast calendar and report loading, stored procedures for transactional logging, structured schemas for predefined plus user custom fields, historical tracking with audit trails. Hosting and cloud infrastructure, Azure App Services. The entire backend is hosted on Azure App Services, providing auto-scaling based on load, high availability, and secure deployment pipelines. App Service Plan defines compute resources, scaling rules, and environment configurations for optimal performance. Azure Security, used for Role-Based Access Control, RBAC, API protection, Key Vault for credential and encryption key management, threat detection and mitigation. Azure Backup ensures daily backups of the database and critical application data for disaster recovery. Email delivery, Microsoft Graph API. All system emails, OTPs, password reset links, partner invites, and notifications are sent through Microsoft Graph API, ensuring high deliverability, secure sender authentication, and reliable email throttling and tracking. Media and Assets, CDN. Images, educational resources, and hospital bag templates are delivered via a content delivery network. This allows instant updates without publishing a new app version and ensures faster global loading times. AI Intelligence, Azure OpenAI. ANIRA, the in-app AI companion, uses Azure OpenAI for context-aware guidance, emotional support, personalized pregnancy and cycle insights, symptom interpretation, non-medical supportive guidance. Requests are passed through back-end filters and enrichment layers before reaching the model. DevOps and Development Workflow, Azure DevOps. Azure DevOps powers CI/CD pipelines, automated builds, code review workflows, task and sprint management, release versioning. The CI/CD system deploys back-end updates directly into Azure App Services, ensuring smooth and safe rollouts. UI/UX design, Figma. All user interface layouts, components, and design flows were created in Figma, enabling consistent design system, real-time collaboration, smooth developer handoff, and pixel-perfect implementation across screens. Together, these technologies give Fertility Nest a fast mobile experience, a secure and reliable back-end, scalable infrastructure, personalized AI capabilities, strong community features, real-time reminders and tracking. This technology stack ensures the app remains robust, adaptable, and capable of supporting users throughout every step of their reproductive journey.